This is Radhika. I'm going to discuss about the power electronic devices. This is for 5th sem electrical students in diploma. So in last class, we discussed about the commutation and class A and class B commutation. Now we are going to discuss about the class C and class D commutation. Now this is the diagram for class C commutation. This is the diagram for class C commutation. In this diagram, the circuit for complementary commutation means class C commutation or complementary commutation. So the circuit for complementary commutation, it is used for main thyristor T1 and a complementary thyristor T2 in parallel with T1. In this technique, if one thyristor is turned on, causes itself the other thyristor gets turned off, and hence it is called complementary commutation. In this has two cases. So in this circuit, it has the R1, R2 in parallel, R1 and R2 in parallel, and this will be connected to capacitors, and SCR1 and SCR2 will be connected in parallel. So here in class C commutation, C or LC switched by another load carrying SCR is used. Class C configuration has two SCRs. One of them may be the main SCR and the other auxiliary. And in this commutation, both may be load current carrying main SCRs. The configuration may have 4 SCRs with the load across the capacitors. So with the integral converter supplied from a current source. Assume SCR2 is conducting C, then charges up in the polarity. It is known as the class C commutation. In case 1, thyristor T1 is turned on by a gate pulse. Load current flows from battery to load 1 through thyristor 1, along with a capacitor charging current flows from battery through load 2. Capacitor C and thyristor T1, this current charges capacitor C to the battery voltage V with polarity. So in this, and also it has the case 2 also. In case 2, the gate pulse is applied. In case 2, the gate pulse is applied to thyristor T2, turning it on. The capacitor voltage now appears as reverse bias across T1 and turns it off. In this diagram. So in this case, load current flows from battery to load 2 through thyristor T2. In addition, the charging current flows from battery through load 1, capacitor C and load 2. This charging current charges the capacitor to supply voltage with reverse polarity, that is polarity reverse of that. So when thyristor T1 is turned on, in the next cycle the voltage across C reverse biases thyristors T2 and turn it off. The above cycle events it repeated continuously in the subsequent cycle. Now we are going to watch one YouTube video for commutation C.
So let us begin this session with first agenda, that is basics of class C commutation. Now see, when we talk about class C commutation, then it is also referred as impulse commutation. Now why it is referred as impulse commutation? The reason is, in circuit you will be observing there are two thyristor, and when thyristor 1 is on, to turn off thyristor 1 we will give gate pulse to thyristor 2, and when thyristor 2 is on, to turn it off we will give gate pulse to thyristor 1. So see, by giving impulse gate pulse to thyristor we will turn off thyristors. So that's why this is referred as impulse commutation. This class C commutation method is also referred as complementary commutation. Why it is referred as complementary commutation? So as I have told you, as if thyristor 1 is on, to turn it off we give gate pulse to thyristor 2. So thyristor 2 will get turned on and it will turn off thyristor 1. And when thyristor 2 is on, we will give gate pulse to thyristor 1. So that will turn on thyristor 1 and it will turn off thyristor 2. So that's why it is referred as complementary commutation. So let us see how all those things are happening. So first I'll explain you class C commutation circuit, where in this circuit you will be observing there is a DC supply. Why there is a DC supply? The reason is class C commutation is there in the category of forced commutation, and in forced commutation our supply voltage will be DC supply. And if you see further circuit, then there are two resistors connected like this. After that there is two thyristor T1 and T2, and over here there is capacitor C. So this is how circuit is there with class C commutation. So now let us try to understand working of class C commutation. So initially I'll consider both of these thyristors are off. So as both of these thyristors are off, voltage across capacitor will be even 0, right? So this is how you can observe both of these thyristors are off initially, and after that I'll turn off thyristor T1. So here by giving gate pulse to thyristor T1 we have turned on thyristor T1. So as this thyristor is on, there are two loops through which current will flow through thyristor T1. You can see first loop is this, that is loop 1, where current will flow from Vs to R1 to thyristor T1, and again it will go inside Vs. So this is one loop, and second loop that will be supply voltage Vs to R2 to C to T1C. That is how second loop is there. Now if you observe current in loop 1, so that current in loop 1 will be Vs by R1. And if you observe initial current in loop 2, then initial current in loop 2 will be Vs by R2. So total current passing through T1 initially, it will be Vs by R1 plus Vs by R2. And here you will be observing current in loop 2 that will be decreasing and it will get to 0 once this capacitor charges by voltage plus Vs, and polarity that will be plus minus like this, right? So once this capacitor is getting charged up to voltage Vs, current in loop 2 will get 0. So after that current passing through thyristor T1 that will decrease to Vs by R1. So initially it will be Vs by R1 plus Vs by R2, and then it will decreases to Vs by R1. Now to turn off thyristor T1 we will give gate pulse to T2. So this T2 will act as a short circuit. Now if you observe this voltage minus plus, so this minus plus voltage that will appear across this thyristor T1. So this minus plus voltage will make this thyristor T1 in reverse bias, and as this thyristor will come in reverse bias, it will get turned off. So you will be observing this voltage plus Vs voltage that will appear across thyristor T1, and it will be in reverse bias. So this thyristor T1 will get turned off. So you can see it over here. Now initially voltage across capacitor is minus plus like this, and I am considering that as a plus Vs voltage. But as this T2 is getting turned on, now current will flow through T2 via two different loops. One loop is Vs to R2 to T2 like this, and second loop is Vs to R1 to C to T2. Now current due to this loop Vs to R2 to T2, that is Vs by R2, and initial current due to second loop, that is Vs to R1 to C to T2. So that will be because of voltage across capacitor plus voltage by supply. So that will be 2Vs by R1. And voltage across capacitor now will change by polarity to plus minus, and this capacitor will get charged from plus Vs to minus Vs. Once this capacitor C charges to plus Vs to minus Vs, current in this loop Vs to R1 to C to T2 will get to 0. So after that only current will pass in this loop, which is Vs to R2 to T2. And current through thyristor T2, initially it will be maximum by the value 2 Vs by R1 plus Vs by R2. And once this capacitor charges to minus Vs, current through T2 that will changes to Vs by R2. So now you can see polarity of capacitor plus minus like this. Now to turn off T2, we can give gate pulse to T1. So when we give gate pulse to T1, you can observe this will act like a short circuit. So this plus minus voltage, so here plus and here minus, that will make this T2 in reverse bias, and this T2 will get turned off. So you can observe now this polarity of capacitor that is having minus Vs voltage plus minus like this, and that will turn off this T2. And now again this voltage across capacitor will changes from minus Vs to plus Vs, and current through T1 that will flow via two loops. One is Vs to R1 to T1 and second is Vs to R2C to T1. And once this capacitor voltage charges to minus plus means plus voltage Vs, then again this state will come, and from this state circuit will be working with same condition. You can see, right? So this is how different modes are working. Now let us try to understand all those things in terms of waveform, so it will be more clear. So here we have this circuit where R1, R2, C, T1, T2, those elements are connected as we have seen. And here in this circuit we will observe total 8 different waveforms that we will be going to see. Ig1 and Ig2, those are gate current which is given to T1 and T2. Vt1 and It1, that is voltage and current across thyristor T1. Vt2 and It2, that is voltage and current across thyristor T2. Vc and Ic, that is voltage and current across capacitor C. Now to understand this waveforms and working, first, as I have explained, initially both of these thyristors are off, and as if we give gate pulse to thyristor T1, so this T1 will get turned on, and as this T1 is getting turned on, current will flow in two different loops. One loop is this, and current because of this loop, that is Vs by R1, and second loop is this Vs to R2 to C to T1. And initially current passing through T1, that will be addition of this two loop current, and that is Vs by R1 plus Vs by R2. But as this capacitor is getting charged, and once this capacitor is getting charged to Vs voltage, current in this loop 2 that will get 0. So at that time current in this thyristor T1 that will be Vs by R1 only. So this capacitor will get charges to plus minus polarity like this, one can see, and consider direction of current in this direction. If you consider that is positive, right, then in opposite to that direction will be negative, that we need to consider. So see, now let us try to understand that by waveform. So here we are giving gate pulse to Ig1, that will turn on thyristor T1, and Ig2 is not on, it is off. So now voltage across T1 that will be obviously 0, right, as T1 is on, and current passing through It1, initially it is Vs by R1 plus Vs by R2, right. and it will decrease to Vs by R1, right, as in loop 2 current will be 0. If you all observe voltage across thyristor T2, so that is initially it will be 0 as it is appearing across capacitor, but once capacitor is getting charges to Vs, voltage across this thyristor E1 will result into Vs. So you will be observing voltage across thyristor T2 that will increase to Vs gradually, as this you can see it in figure. And current across thyristor T2 will be 0, and voltage across capacitor that will be same as voltage across thyristor T2. So it will happen like this. And current across capacitor, initially it will be Vs by R2 and it will decrease to 0, you can see. So that is what the case which will happen. Now here thyristor T1 is on, and to turn off thyristor T1 we will give gate pulse to thyristor T2. So as we have given gate pulse to thyristor T2, polarity of capacitor is plus minus like this, and that will appear across thyristor T1, and that will make this thyristor T1 in reverse bias, and that will result into thyristor T1 will get turned off. So this voltage will turn off this thyristor T1 as this capacitor voltage will make this thyristor T1 in reverse bias. So now this thyristor T1 is turned off, and initially capacitor voltage is plus minus like this, that one can see. Now current passing through T2, that will be in two loops. One is Vs to R2 to T2, and second is Vs to R1 to C to T2, right? And these two currents that will result into initial current in T2, that is equals to Vs by R2 plus 2 Vs by R1. Now why there are 2 Vs by R1? The reason is capacitor voltage plus Vs. So in loop 2 current is 2 Vs by R1 like this, and there will be capacitor current till this capacitor polarity is getting changed. So once this capacitor is getting charged by this polarity plus minus, there will be flow of current, and that current will decrease to 0 once this capacitor voltage will changes to minus Vs, that is having this polarity plus minus. So here capacitor voltage will changes from plus Vs to minus Vs. Current through T2 that will changes from 2 Vs by R1 plus Vs by R2 to Vs by R2, right? So let us see all those things by waveform. So see, as we are giving gate pulse over here, T2 will get turned on and T1 will get turned off. That I have told you, like that voltage across capacitor will make T1 in reverse bias, so T1 will be off. Now voltage across thyristor T1, so now that you can see it will be Vs initially and it will be minus Vs. Why? The reason is initial capacitor voltage will appear across thyristor T1, and that voltage will change its polarity, right, to minus Vs across capacitor, and that will appear as plus Vs across T1. So now voltage will changes from minus Vs to plus Vs across thyristor T1, that you can see. If you observe current through thyristor T1, so that will be 0. You can see it is 0. And if you observe voltage across thyristor T2, so as it is on, voltage across thyristor T2 will be 0. Current across thyristor T2, initially it will be 2 Vs by R1 plus Vs by R2, right? So you can see, and it will decrease to Vs by R2, and at the same instant you will be observing as it is decreasing to Vs by R2, voltage across capacitor will changes to minus Vs, right? So you can see plus Vs to minus Vs, voltage across capacitor is getting changed, and at the same time current in capacitor that is flowing till voltage across capacitor is reaching to minus Vs. So till this instant only current will be there. Initially it will be maximum and it will decrease gradually. Initially it will be minus 2 Vs by R1 and it will decrease to 0, you can see. Now to turn off thyristor T2, we can give gate pulse to T1 and that will make T1 turn on and T2 turn off. And this waveforms which is there in this T1 on will appear over here, right? So I'm not plotting it again. So that is how complementation of commutation is happening in classic commutation. I hope that you have understood this session. Please do give your valuable suggestions.
So now we can watch the YouTube video lesson for class C commutation. Now we are going to discuss class D commutation. Now, uh, I'm going to discuss about the class D commutation or impulse commutation. So this is the diagram for commutation D. So in this method of commutation uses a capacitor, an inductor and the auxiliary thyristor to achieve the commutation of main thyristor. So in this diagram, the auxiliary commutation is the auxiliary commutation circuit. T1 is the main thyristor and TA is the auxiliary thyristor. In this SCR, so SCR-M is the main thyristor and SCR-A is the auxiliary thyristor. So in this, just we assume that the capacitor is initially charged to voltage Vc with the upper plate positive. The commutation process can be described by the following two modes. So mode 1 is main thyristor T1 is triggered by a gate pulse. Load current flows from the battery through T1 and load. At the same time, capacitor also discharged through T1. The path for this capacitor current is through T1. Diode D and inductor L at the end of this mode. Capacitor C gets charged to opposite polarity. That means lower plate positive. The diode D does not allows reverse charge of the capacitor. So here D is the diode. And in mode 2, to turn off the main thyristor, the auxiliary thyristor TA is turned on by a gate pulse. The capacitor voltage appears as reverse bias across main thyristor T1. The capacitor C starts discharging through TA and T1. This discharge current is flowing from the cathode to T1 when this current becomes equal to load current flowing through T1. The net current is T1 becomes 0 and it is turned off. At the end of this mode, T1 is turned off and capacitor C is charged with upper plate positive so that mode 1 can be repeated. This commutation technique is achieved with the capacitor voltage and hence it is known as voltage commutation. So this is the about class D commutation. So this is the class D or impulse commutation. So now you can watch the YouTube video about the class D commutation.
I have explained you in lecture number 6 in discharging LC. Hi guys, in the previous lecture, that is the lecture number 31, we have covered the class C commutation, that is also known as impulse or complementary. Okay, and here inductor and capacitor and diode are connected in this manner, and we have to turn off this main thyristor. My job is to turn off this main thyristor. So let us see how I am turning off this main thyristor. I am assuming that initially the voltage drop across this capacitor, this is the capacitor, right? So voltage drop across this capacitor is equal to supply voltage, and polarity of voltage drop across this capacitor is from plus to minus, like this. This is the assumption. For t less than 0, the voltage drop across this capacitor is Vs. And the second assumption is load current is constant. Okay, load current is not changing, it is constant, means we are dealing with highly inductive load. Okay, so these all commutation circuit, that is the class D commutation, is divided in 3 mode 1, mode 2 and mode 3. We will see separately one by one. First we will talk about the mode 1. In mode 1, what I am doing, I am turning on the main thyristor at t is equal to 0. See the waveform Tm, this is the main thyristor, right? So main thyristor is on at t is equal to 0. So the moment when main thyristor will be on at t is equal to 0, means it will be shorted, like this. Okay, and auxiliary thyristor we have not turned on, so it will be off. So this capacitor will discharge from Tm, main thyristor. Diode will be in forward bias because positive plate of this capacitor is connected with anode, so diode will be shorted, and this inductor. So overall this is the discharging LC circuit. Okay, so the moment when I will trigger this main thyristor Tm, so this Tm will be shorted and this capacitor will discharge across this inductor, means capacitor will give energy to this inductor, and again this inductor will behave like a current source and it will give energy to this capacitor, and at the end the voltage drop across this capacitor will be somehow like this, from minus to plus. Got it? Same thing is happening. The moment when voltage drop across this capacitor will be from minus to plus, here diode, see, let us see, this is plus and this is minus. This diode will be open circuited because this diode won't allow the further current flowing in reverse direction. Okay, so in mode 1 I am triggering this thyristor Tm, due to which the voltage across this capacitor get reversed. This capacitor will deliver energy to this inductor, again this inductor will deliver energy to this capacitor. So if I will ask you what is the capacitor current IC of t, see here IC of t, this is discharging LC circuit, right? IC of t will be ICP sin omega naught t, where ICP is equal to Vs under root C by L and omega naught is equal to 1 by under root LC. These all things I have explained you in lecture number 6. In discharging LC circuit, the capacitor current I am getting ICP sin omega naught t. So capacitor current after t is equal to 0, I will get ICP sin omega naught t like this. This is the capacitor current. It will be sinusoidal from 0 to t1. Got it? The capacitor current will be sinusoidal. After pi, the current is not going to the reverse because of this diode. So current I will get, capacitor current I will get only till pi. This is the pi. Got it? After pi, the current will not be reversed because of this diode connected in series with inductor and capacitor. Is it fine? So finally IC of t is equal to ICP sin omega naught t, and this is the maximum current, that is equal to ICP. Okay, now tell me what is the voltage drop across capacitor. See, voltage drop across capacitor Vc of t, I will get Vs cos omega naught t, means it will be cosine wave. So cos omega naught t will be like this, it is pi by 2, and at pi it will be minus Vs. If you will put cos pi, that you will get Vc of pi, that is equal to minus Vs. From 0 to t1, the capacitor voltage is changing from plus Vs, this is plus Vs, to minus of Vs. So capacitor current is equal to ICP sin omega naught t and capacitor voltage is equal to Vs cos omega naught t. This we have discussed in lecture number 6, and I have drawn the waveform of capacitor current as well as capacitor voltage. Got it? Now see in mode 1. In mode 1, what will be the output voltage? See, thyristor, main thyristor is conducting, right? So main thyristor is conducting means output voltage is equal to Vs only. So in mode 1, output voltage is equal to Vs, like this. Okay. So from 0 to T1, this is the mode 1. This is the mode 1. Okay. Now if I will ask you what is the current flowing in main thyristor, that is the ITM. This is the main thyristor current. So main thyristor current will carry the current of load current as well as the capacitor current. See, when I will trigger this main thyristor, then capacitor current will flow from left to right in the main SCR. Okay, and load current will also flow from the main SCR only. So what will be the ITM? In this case, the ITM is equal to I naught plus IC of T in mode 1. Okay, so I naught, let us say this is I naught and it is constant. So if I will add I naught and IC of T, I will get ITM. So ITM will be somehow like this: I naught plus ICP sine omega naught T from 0 to T1. Okay, now see the mode 2. In mode 2, what I am doing? See, at the end of mode 1, what is the voltage drop across this capacitor? The voltage drop across this capacitor is from minus to plus, and that is equal to Vs. Okay. Now in mode 2 will start from this. This is the mode 2. Okay, this is mode 2. Mode 1 is from here to here. So in mode 2, what I am doing? I am triggering the auxiliary thyristor. TA is on at T is equal to this much. Okay, so when TA will be on, this auxiliary thyristor, I am triggering this auxiliary thyristor at T is equal to T2. Got it? So the moment when auxiliary thyristor will be turned on, see the voltage drop across main thyristor. Let us say this is Tm. Okay, and this capacitor is charged in this manner. So I can say that this TA is triggered means positive plate of this capacitor is connected with cathode and negative plate of this capacitor is connected with anode. So it is minus, it is plus, and this is capacitor. So the moment when TA will be triggered, the voltage drop across main thyristor will be negative. See here, this is VAK. So VAK will be less than 0 because of the polarity of voltage drop across this capacitor in this manner. Okay, so VAK will be less than 0 means this main thyristor will go into the reverse blocking mode and it will turn off. So the moment when you will turn on this auxiliary thyristor, that is TA, this thyristor, main thyristor, will be in off state. It will go into the off state. Got it? So at omega t, this is at t is equal to T2, the main thyristor current, what will the main thyristor current? ITM will be equal to 0 because it will go into the off state. When TA will be on, then ITM will be 0 and it will go into the off state. So in mode 2, what will happen? See, in mode 2, the supply voltage is again charging the capacitor. The capacitor voltage is from minus to plus, so supply voltage again charging the capacitor from plus to minus. So capacitor voltage drop across this capacitor will decrease from minus Vs to 0 and again it will charge to plus Vs like this. Okay, so this is the case of mode 2. In mode 2, what we are doing? We are triggering this main thyristor, we are triggering this auxiliary thyristor TA in mode 2, that is at T is equal to T2. Okay, so the moment when I will trigger this auxiliary thyristor, the voltage drop across main thyristor will be minus Vs, means it will be in negative. So main thyristor will go into the reverse blocking mode and it will turn off. And again the capacitor voltage, the voltage drop across capacitor, the Vs, supply voltage charging the capacitor. So capacitor voltage increases from minus Vs to 0 and again it is charged to plus Vs like this. It will charge to plus Vs in mode 2. Got it? Now see one more point. When TA will be on, then what will be the output voltage at that time? V0 will be what? See, when TA will be on, then at that time the capacitor, the voltage drop across this capacitor will be from minus to plus and it is equal to minus Vs. Okay, and TA is on means it is connecting like this, and this is V0 and this is supply voltage. okay, in this manner, because main thyristor will be off when TA will be on. So apply KVL, you will get minus Vs plus V naught, that is equal to 0. Apply KVL, minus Vs, voltage drop across capacitor will be minus Vs plus V naught is equal to 0. So V naught will come out to be 2 Vs. So the moment when TA, auxiliary thyristor, will be on, at that time the output voltage will be equal to 2 Vs. This is the output voltage, that is equal to 2 Vs. Got it? So when TA will be on, then output voltage will be equal to 2 Vs, and it will start decreasing linearly like this, because the capacitor will charge from minus Vs to plus Vs, and when this capacitor will become equal to plus Vs, the output voltage will be equal to 0. See, when this capacitor voltage will be equal to plus Vs, then output voltage will be 0. So it is like this. So output voltage waveform I will get somehow like this. Voltage drop across capacitor, the waveform voltage drop across capacitor will be like this, and output voltage will be like this. So if I will have to explain all the mode, then how will I explain? See, at t is equal to 0, I am triggering the main thyristor. Okay, so the moment when main thyristor will be triggered, then this voltage across capacitor will discharge from main thyristor, diode and inductor. So all the energy present in the capacitor will be given to the inductor, and again inductor will give energy to the capacitor, and at the end of mode 1, the voltage drop across this capacitor will be minus to plus like this. Okay, after that in mode 2, what I am doing, I am triggering the auxiliary thyristor. When auxiliary thyristor will be triggered, then the voltage drop across this main thyristor will be negative because of this capacitor. See, when I will trigger the auxiliary thyristor, then the voltage drop across main thyristor will be negative, means this main thyristor will go into the reverse blocking mode and it will turn off. So when TM will be on, then TM will go into the reverse blocking mode and it will turn off, and again supply will charge the capacitor in the first manner, that is from plus to minus, and at the time of triggering of auxiliary thyristor, the output voltage I will get, that is equal to 2 Vs by applying KVL. Okay, in this way I will get capacitor current, thyristor current, main thyristor current, voltage drop across capacitor, as well as the output voltage. Now we will find the formula in each and every mode. So first formula, we have to find peak value of current in main thyristor. See the peak ITM waveform. So this will be the peak value of current in main thyristor. This is equal to I naught plus ICP, we have already found. So peak value will be I naught plus ICP, that is equal to I naught plus Vs under root C by L. Now ITA peak, what is the peak current in auxiliary thyristor? See, in mode 2, I am triggering the auxiliary thyristor, right? So auxiliary thyristor is nothing, the current flowing in auxiliary thyristor is nothing but it is equal to the load current only. You can see that when TA will be triggered, TM will be off, and in this time the load current is equal to the auxiliary thyristor current. So it will be equal to I naught. Now say third point is minimum turn off time of TM, main thyristor. We have to find the minimum turn off time. See, here I am triggering the auxiliary thyristor at this time T2. Okay, now if I will trigger the auxiliary thyristor at this time, when I will trigger the auxiliary thyristor at this time, then TM, this main thyristor, will go into the reverse blocking mode at this time only. Okay, so what will be the turn on time of minimum turn on time of main thyristor? Minimum turn on time of main thyristor will be equal to T on, and that can be found by ICP sine omega naught T, that is equal to 0. So omega naught T will come out to be pi, so T will come out to be pi under root LC, that is equal to T on. This is pi. Okay, this is pi. So minimum turn on time of main thyristor I will get when TA will be on at omega t is equal to pi. Okay, so minimum turn on time will come out to be pi under root LC, and that is also equal to minimum turn off time. Okay, now the fourth point is circuit turn off time. We have to find the circuit turn off time. Circuit turn off time is defined as the time for which thyristor, main thyristor, is in reverse bias. See here in mode 2, main thyristor is going to off. When TA will be triggered, then this TM will be in off state because of negative voltage drop across this thyristor like this. This is the polarity na. So negative voltage will drop across this main thyristor, so it will be off. So I can define the circuit turn of time, that is the time for which thyristor is in reverse bias. So thyristor is in reverse bias when the voltage across this thyristor will be in negative. So when capacitor voltage will be negative means this is in reverse bias. Got it? Reverse blocking mode. So see here, capacitor is negative from minus Vs to 0. Okay, after that the voltage drop across this capacitor will be positive, so this thyristor will go into the forward blocking mode. But circuit turn of time is defined as the time for which the thyristor is in reverse bias. So thyristor is in reverse bias for this time only. This is the circuit turn of time. So how will I find this TCM? See here, we know that Vc of t is equal to 1 upon C integration of I dt. Okay, so I can say that when voltage drop across this capacitor will move from minus Vs to 0, this is Vc of t is equal to 1 upon C, circuit, we will get circuit turn of time 0 to TCM, and in this range the current flowing in this capacitor will be equal to I naught, so it will be I naught dt. So find this, you will get TCM, circuit turn of time, that is equal to CVS upon I naught. This is the circuit turn of time of main thyristor. So it will come out to be CVS upon I naught. What is the conduction time of auxiliary thyristor? See, auxiliary thyristor is conducting, TA is on from here and TA is off here. So auxiliary thyristor is conducting from here to here, that is equal to 2 TCM. So it is equal to 2 TCM, that is equal to 2 CVS upon I naught. Last one is the output voltage. Output voltage I can easily find in one cycle. In one cycle output voltage is this much. So if I will find the area under this waveform, then it will give the output voltage. Now this is the time T on. Total on time of main thyristor is this much. So this is T on and this is 2 TCM. After that this is 2 TCM. So it will come out to be Vs into T on plus, this is triangular waveform, so it will be 1 by 2 into 2 TCM peak voltage, that is 2 Vs. So it will be equal to 1 by 2 into 2 Vs into 2 TCM upon total time T. Okay, so finally it will be equal to Vs into T on plus 2 TCM upon T. This is the average output voltage in class D commutation. Okay, so these all formula you have to keep in mind, then only you would be able to solve the problem based on class D commutation, that is the voltage commutation. Why this is no?
So now we watched the class D commutation YouTube video. Now today we discussed about circuit diagram of class C commutation and working of class C commutation, circuit diagram of class D commutation, and working of class D commutation. So here we have the few quiz questions and few frequently asked questions. Next class we are going to discuss about the class E and class F commutation. Thank you.